In this video, I'm going to share 5 key concepts, or more like sayings, about the brain and nervous system that I think will greatly develop your understanding of how movement works. These are things that we can kind of look to when traditional movement approaches don't seem to be working the way that they should. And so the purpose, I guess, really of this video is not to give you tools that you can take away and use right away, but more to kickstart a thinking process. So hopefully it's going to spark a little bit of curiosity that helps you think a little bit differently about how movement really works. And like I said, this isn't going to replace any traditional movement practices, but really it's more for when we run into problems. So we're not seeing the progress we would expect to make. We try something, we think it should work one way and it doesn't. Usually thinking about some of these things will give us an insight into how it goes. So let's get into it, I guess. So number 1, the first saying, this is going to be the most important one, and everything really is going to tie back into this, and that is that the brain's job is survival through movement. So survival should be a pretty obvious one. Pretty much every system in the body is biased towards survival. That's how we survived this long. That's how we're still here. The movement one is the one that's really important, though. If you look at any organism in the world, the ones that have nervous systems are the ones that do a lot of movement. The more complex the nervous system, usually the more complex the movement, and the ones without nervous systems tend to probably involve a little bit of movement. They're all going to grow and they're going to transport nutrients around them and stuff like that, but the movement aspect is severely reduced. So we can say that the brain's job is almost entirely, in fact probably entirely governing and regulating movement and interpreting the movement of the outside world. One of the important things that it has to manage this is reflexes. So we have a ton of reflexive outputs that are built in for protection, but also for our performance as well. So basically, to reduce thinking time and to reduce energy consumption, our brains will, it's almost like writing set pieces of code. So if something happens, rather than thinking of each individual step, like I'm thinking about raising my arm right now, I'm not thinking about every single muscle that has to activate. The brain has tons and tons and tons of these reflexive outputs that are built in so that we don't have to think so quickly so often. If a certain stimulus happens from the outside world, we just kind of act straight away. There's usually a threshold to this, so some reflexes, which we would know as like the physical reflexes, happen above our conscious level of awareness. That means while we cannot control them, they happen and we aren't really able to stop them from happening. The classic example of this is somebody comes up behind me, claps her hands, makes a loud bang, and I jump, and you see my shoulders lift up to protect my neck, my arms are crossing my midline, I'm probably going wide-eyed. I didn't choose to do that. If I could choose, I would probably do something much cooler, but it still happened nonetheless, and I'm very aware of it happening. And no matter what, even if the stimulus wasn't so intense, so if they made a bang but it wasn't that scary, I'd probably still be aware of that motor pattern firing in my body. Like I would feel my shoulders start to get a little bit tense, even though they don't physically lift up. So pretty much everywhere on that continuum, that startle reflex, I'm going to be fairly aware of. There's a whole other load of reflexes as well, though, that happen completely below my conscious level of awareness as well. So examples of this, my eyes usually have a lot of reflexive muscle firing associated with them, because usually when my eyes move, my body is going to move in a certain direction as well. So if I just lift my eyes up nice and quickly, look up to the roof, all of the extensor muscles will fire all the way down my back, or if I look down, the opposite will happen. So the extensor muscles will relax and the flexor muscles will fire. You can try that right now. You're probably not going to be aware of it happening, but below our conscious level of awareness, it is happening. Now, this is kind of important for survival, because in terms of survival, there's really two aspects. There's short-term survival and there's long-term survival. Short-term is obviously going to take priority. If our brain perceives us to be in immediate danger, it's not gonna hang around. It's not gonna let us think about what to do next. It's just gonna fire those reflexive outputs into action. So that startle reflex, where somebody come up, claps their hands behind me, that's an example of my body reacting to some perceived short-term danger. I didn't have any choice. It just fired it because it's safer in the long term. It's safer for me to always act on potential threats than it is to consider my options and maybe suffer a severely damaging, if not fatal, blow. After the short-term stuff has been dealt with, though, our brain then wants to think about long-term survival. So if we don't perceive ourselves to be in any immediate danger, the next thing we want to do is think about, all right, well, how can I maximize my chances of survival long-term? So in the short term, we have that kind of fight or flight. We've got to run away. We've got to just use a lot of energy really fast, using maybe reflexes that are above or below our conscious level of awareness. In the long term, we're thinking about the kind of rest and digest side of things. So that is going to be catching up with our sleep, trying to get all of our autonomic functioning back to normal. So maybe we regulate our breathing to make sure it's a bit more useful than hyperventilating or overbreathing that we might have been doing in the fight or flight stage. We're going to allow our muscles to repair. We're going to try and flush toxins out of our system. And the other really useful thing is we're going to start learning things. So based on the threats, the short-term immediate threats that have come up, or once we've got rid of the threats, our brain's going to go, okay, cool, what do I need to learn to make sure that I'm better able to deal with this next time? The kind of important thing to note here, based on these reflexes, I think it's worth bearing in mind that if our brain will always act in our short-term interests over long-term, and learning is a long-term interest of the brain, it's worth noting that if there are any aspects of our physiology that our brain perceives to be threatening in that moment, whether that is above or below our conscious level of awareness, so above might be some psychological stress that I'm feeling. I might be super stressed about my job or relationships or family life or money. It could be physical. I might be very well aware that I've got an injury somewhere, and my brain is going to think, okay, that could well be a problem. That's something that I need to think about always in the short term, because if I do anything stupid, that could become much, much bigger. There's also things below our conscious level of awareness as well. So maybe our balance system, because I've just got over the flu, or I've been out for a friend's birthday and I was drinking, and my inner ear canals have not quite recovered yet, so my balance is feeling a little bit worse off. Or maybe something a little more long term, and the balance systems have actually degraded a little bit, so that now all the time they feel like they're overwhelmed and overstressed when I'm moving around through space. If the brain sees that as a threat, it's also going to try and cause some reflexive actions to make you act in the best interest for the short-term survival of that system. So if my brain doesn't think it's balancing well, it's going to do everything in its power to make you not challenge the balance systems, whether you're aware of that or not. So maybe it gives you pain in your feet or ankles. Maybe it slouches your posture, so if you do fall over, you're already closer to that kind of protective, startled fetal position. Maybe it just lowers your mood, so it makes you feel a little bit less happy and enthusiastic and excited, so that you're less motivated to go out and do some crazy movement practice. I think that's really useful to note, because a lot of the time when we think about what's going wrong in the physical training that we're doing, whether it's our weightlifting, flexibility work, or learning a new skill, we think solely about the technique of what we're not doing right. But if our brain is thinking about short-term survival, maybe it's putting in blocks that mean we're never actually going to be able to address that technique, or it's going to be a super long process if we are, because the survival side of things is going to be fighting with my conscious will. As an example, if I've got a really heavy weight over my head and there's an explosion behind me, there's going to be a fight in my brain of, do I keep this over my head because I don't want it to hit me, and do I just go into that natural startle reflex? And those muscles are going to fight each other, and probably afterwards I'm going to be in quite a bit of pain or discomfort, if not having some structural damage as well. So always worth remembering that the level of threat that the brain perceives itself to be in, whether it's globally among the whole thing or not, whether it's just localized in one particular area, can really affect the conscious movement that you're trying to do, and you might not always be aware of it. Okay, so I've spent quite a long time on just that one point. I'll try to move through the next ones a little bit quicker, but that one I think is really important to understand. Do get back to me if I need to make that any clearer. The final point about survival through movement is the brain is only interested in movement. So pretty much, I kind of wanted to put this in because a lot of people think about the brain as just those kind of abstract thoughts that we get. So when a lot of research gets published about the brain, media usually shows up the ones that are to do with things really in the frontal part of our cortex. So maybe the actual frontal lobe, or maybe the emotional systems or memory systems, things like that, which are all quite advanced systems. And so we might imagine that movement doesn't really play much of a part in what the brain does, because memory, you don't really need to move to remember things. You don't really need movement to feel emotions, to do math or language. We don't really see as a movement practice, even though language actually involves very complex movements from our vocal cords and our larynx and our jaw and our tongue. So actually, at the base level, it is a movement. All of those other things also are only possible when movement is an option in the world. So even if you're completely paralyzed, the fact that you're thinking complex thoughts about what other people might say or do is only useful because those people can move around. So movement actually is the sole purpose of the brain, and anything that's more complicated is just an advanced function of movement, if that makes sense. That's going to be useful later on. I'm going to come back to that, where we talk about treating things like your emotions, your focus, things that, or your memory, things that we wouldn't normally associate as movement-based, can very often be treated with movement. And I think a lot of research is coming out now, especially in terms of mental health, that movement is really useful. So anyway, that's long enough on concept number one. Let's move on to the next topic. So we've looked at survival through movement. The next thing we're going to look at is how different parts of the brain survive. So basically, for any neuron in the brain to survive, it needs fuel and activation. And you'll be familiar with the idea of use it or lose it. So anything that you practice, you get better at. Anything you don't practice, you're going to forget. This is really just an advanced concept of survival. So given that we all need fuel to survive, we all need glucose and oxygen, especially for our nervous system. We need various nutrients to keep the other cells in the body fueled appropriately and built up appropriately. The problem with that is the fuel source is potentially finite. So as far as our brain's concerned, we could run out of glucose at any given second, or we could run out of oxygen at any given second, and therefore it has to decide. In a perfect world, it would just fuel everything equally all the time, and we'd always be capable of doing whatever it is that we want. That's not the reality, though. So what the brain has to do is decide from when we're born and we get all these brain cells and we have all these connections, it's got to decide, all right, which ones do I actually need to use? So in this kind of perfect environment where we've got a huge fuel supply, so we're breathing really well, we're getting enough oxygen in, and we're getting to eat regularly, and our body's able to convert enough of that into glucose so that it can be supplied to our brain and nervous system. The first thing the brain's going to ask is, all right, which neural pathways are being activated more often? Okay, so which ones are the ones that are actually getting used all the time? Which ones are asking me for some energy? And in a perfect world where I've got ample supply of energy, it's going to fuel those ones. It's not going to fuel the ones that don't need it. It would prefer to actually keep a store of some energy in case it runs out a little bit later on. So that's where that use it or lose it kind of saying comes in, is that the parts of your brain that ask for energy the most will get the energy, the parts that don't ask for it will not get the energy, and eventually they're just going to die off. If they don't get fueled for long enough, they're going to die off. The second part of this, though, is what happens if we're not getting all the fuel that we might want. So either glucose or oxygen is reduced, and this is going to be a lot more common than you might think. So glucose obviously has to be broken down and digested, so if you're not eating at the right time of the day and your energy levels are really high, there's a good chance that at certain times of the day, certain parts of the day, you're going to run out of glucose, and your brain is then going to have to decide, all right, which parts are going to get it. Breathing as well, oxygen, even though we breathe all the time, actually sometimes we can be over breathing, we can be taking in too much oxygen, and that means we're not able to swap the oxygen and carbon dioxide to get new oxygen into the blood, or the oxygen doesn't get long enough in the bloodstream to be able to get delivered to the correct cells. So we might be making the same choices about the oxygen. In that case, it's got to decide, all right, so I know all the things I would like to be using, I know all the things that James is asking me to use, which ones are the most important? And it's actually got, in terms of the brain's organization, it's got a really nice way of doing this. So the most important stuff tends to be all grouped together, and then the least important stuff, that's not to say it's not useful, but it's the least vital to staying alive, tends to be further away. And we can almost think of it as a feed-forward pattern. So most important at the back and the bottom, round about where your brainstem is, at the top of your spinal cord. Least important all the way at the front here in the frontal cortex. To give you an example of those two systems, brainstem is things like breathing, heart rate, a lot of kind of movement, basic movement patterns and rhythms, and muscle tone and posture, things like that, or at least around that area. You can imagine those are the things that are super important if we're going to survive. If all my muscles just stop working, I'm going to collapse in a heap on the floor. So I won't be able to do anything more complicated than lie down. If my breathing stops working and my heart stops beating, I'm not getting any fuel anywhere anyway, so the fuel supply will just run out. So that part of the brain is going to get the fuel first. Then it's going to travel and it's going to get allocated to wherever it feels like it needs until it gets to the front. So the frontal lobe of the brain, the frontal cortex, deals with a lot of conscious kind of thoughts. So that could be your math problems, it could be inhibition, so when you feel hungry but you decide you're not going to eat right now, and just a lot of more complicated thinking processes live in that frontal part of the brain, which is great. It makes us be able to do better things, but it's not so important right away. So in that case, if we have a limited fuel supply, it's all going to get delivered to the back, and then we're going to find, oh, I'm hungry, give me the food, I want to eat it, or I'm not able to make really good decisions, or my willpower, I feel like my willpower is greatly reduced because I'm not able to say no to things. So that's really useful to know for two reasons, actually. So number one is probably a cheap way to say this, but if you want a way to fuel up as much of the brain as possible, so if you've got enough fuel coming in terms of glucose and oxygen, you want to give as much energy to the brain as possible. Well, if you ask this frontal cortex of the brain to work, so with like complicated games with different rules, or go or no go challenges. So when you see a red light, you've got to go. When you see the green light, you've got to stop. And obviously mixed around, so different from how you would expect. Those kind of challenges require quite a bit of fuel to the frontal cortex, so it's not going to get there unless all of the rest of the systems in the brain are happy. So if you want a way of getting your brain fired up and able to work as well as possible, probably frontal cortex challenges are going to be really useful. Similarly, if you find that actually those things are much harder, so maybe your frontal cortex, so those conscious focused attention tasks are really difficult, maybe it's even further back, so you're struggling with your memory or your language, you just can't find the right word for what you want to say very often. It could be that one of the more primitive systems in the brain, so maybe your vision, maybe your inner ear balance, maybe your breathing, is experiencing high levels of threat. So if we remember from the slide before, if my balance system thinks it's really threatened right now, my brain's going to think in the short term, and it's going to only want to address that problem. So it's going to pump a huge amount of energy into the vestibular system to try and sort the problem out. If it's a chronic problem, it might not be able to sort that out without paying attention to it and working on it. So if we were to assess that and we were to try to resolve any balance issues, we might find it easier then to get fuel to other parts of the brain that need it. So two kind of ways that can be useful. All right, let's look a little bit more of the activation side of things. So now, in terms of activating the brain, we still are thinking about survival. We're still thinking about conserving energy. So we move on to concept number 3, which is that neurons that fire together wire together. I really like this saying because you can flip it around. You can also say neurons that wire together fire together. Hopefully that'll become clear in just a second. And this is the idea of, all right, so you're activating loads of different parts of your brain. What's going to want to happen now is, to conserve energy, your brain is going to want to strengthen the connections that get used more. So before we were looking at which connections would die off, now we're going to look at how the brain is going to strengthen the connections it's using a lot. So if we ask the brain to do lots of things at the same time, so let's say walking as an example, when I walk, when I swing my right leg forwards, my left arm also swings forwards. There's some rotation in my spine, and my vestibular inner ear canal registers that we're moving forwards. Well, if we keep doing that over and over again for 10,000 steps a day, or however often we walk, our brain is going to strengthen up those connections so that when one motion happens, it assumes that all the rest will happen. So if I swing my right leg forwards, it's going to assume my left arm is also going to want to swing forwards. So I might find that even if I'm not consciously aware of it, flexion in my right leg, so lifting my right leg up, is also going to fire some of the muscles in my left arm that are involved in flexion. And that's this idea that the neurons that are firing together, when they always fire together, they wire up and the connections solidify so that they're always firing together as well. That's pretty much how habits work. So that kind of works for everything. So good things like walking or learning to play tennis. When I go for my first tennis lesson, I'm absolutely rubbish, but I use up a ton of energy because I'm trying really hard to figure out what's going on. If I was to play against Roger Federer and he matched my level of my level of force output, he was hitting the ball just as hard as me and just as precisely as me, he would be using much less energy because all of the neurons in his brain have wired up to just allow him to do that effortlessly. what was I trying to say with that? Yeah, so it also happens with negative things as well, like pain. So if I'm the kind of person that stretches my splits always into maximum levels of pain, it hurts a lot, and I think no pain, no gain. Well, guess what? Next time I slide into my splits, my brain's going to remember, oh yeah, this is supposed to hurt. That's how we know we're doing it right. So I'm actually more likely to experience pain because those neurons again have those connections have wired up and they're firing together at the same time. What's interesting about this is, let's say now we've got a problem in a certain area. So let's say our inner ear balance system, which we talked about in the first one, is experiencing some threat. So it doesn't like me to be moving around. Well, if we examine it and we say, okay, well, what is it connected up to most closely? Well, our inner ear balance systems connect up really well with our eyes. So if we find that we're getting, let's say, motion sick, or we can't go for a run for very long, we could start training the eyes instead, because we know that by moving the eyes around, because they're so closely connected to the balance system, those two things are going to fire at the same time. So if we're not getting much response from the balance, we can look at the other systems that are involved. Another one we might look at is the neck, because there's some very strong connections. When our head moves, then it's usually by moving our neck. So the inner ear fires as the neck moves as well. As a simpler example, most people are aware of this idea: if I had a really stiff knee, in a lot of biomechanical practices, they say, why don't you look at the joint above or the joint below? So it's kind of the physical manifestation of this neurons that fire together, wire together. It's like the parts of the body that are closest to each other probably influence each other, because if I move my ankle or my hip, those muscles are connected to my knee, so I will probably get some amount of motion in my knee, even if I can't move it right now. I find that one really, really cool, because if I understand how the brain works and how those connections are grouped together really well, it means I can start bombarding. I could use, let's say, neck movements and eye movements at the same time, or resistance in my neck while performing eye movements to activate my inner ear if it's not working really well. Or I could use right ankle circles as well as maybe left elbow circles to activate my right knee if my right knee is stiff. If I know how all of those things are combined and work together, then I can start influencing them from different and sometimes quite strange places. So that's quite cool. It also comes back to this idea that movement can be really useful for influencing a lot more of the brain than we might have thought. So if we're having problems focusing, could that be affected by movement? Probably. If we knew something that would affect the frontal cortex, that would be great, because that's where I look at proper focus. But if I know what other systems that is linked to, like maybe eye stabilization exercises, I might be able to use eye movements again to work on my focus, or I might be able to use different movements that might affect my emotional ability or my memory ability. So using the principle of neurons that fire together, wire together, we can almost treat many more things that don't seem like they're movement based, but use a movement approach to at least influence it. So again, I think that's really cool. Okay, final two concepts are a little further away from this survival principle, but the next one is that change happens at the speed of the nervous system. And the reason I think this is useful is when we often think of movement practices, we're thinking about changing muscle tissue. So if you're doing a strength program, you're trying to build muscle, you're trying to make the muscle tissue, you're trying to make more muscle tissue essentially. Or if in a flexibility program, you're trying to allow your body, the muscle tissues, to adapt to allow more stretch in the muscles before they force a contraction. And even the same with learning a skill, you're trying to sort of toughen up certain parts of your body or make certain parts of your body react much quicker. Well, that all takes time. Let's take your strength program or your flexibility program. You're probably going to talk 12 weeks minimum before you start to see an amount of change that you think, oh, this really worked for me. Well, 12 weeks is a long time if you find out that actually you've taken a flexibility program and in 12 weeks time you've actually got worse. Well, that's 12 weeks of a waste of time. Now, while the nervous system doesn't create huge changes any faster, it creates changes much quicker. So actually the nervous system responds almost instantaneously. There are signals going in and out of the brain, billions if not trillions of signals going through the brain every second, and we can probably notice changes in the nervous system. If we know what to assess, we can see these changes happen in less than 2 seconds. Some examples of things that might change in that time are range of motion. So our flexibility might actually change within 2 seconds. That's because flexibility often is not the state of the muscle tissue, but how quick the muscles will contract when they think they're stretching too far. It could be our balance, so how quickly the brain is able to respond to loss of balance. That ties in really well with our coordination. It will do other things like immune function might go up or down very slightly, and concentration and focus probably going to change. But all of these things will happen in less than 2 seconds, and they will happen based on, again, what does the nervous system think of what's happening to it in terms of survival. So a slightly stressful stimulus that the brain thinks it can handle will cause it to think about long term. It will say, hey, this is a bit stressful right now. I want to make this easier, so I want to learn about this so that I'm better able to deal with it in the future. If the stress is too high, then it's going to say, oh, hang on a minute, this is too much. I want to escape, and it's probably going to produce a negative reaction. So if we get good at assessing the nervous system, while we won't see the long-term changes really quickly, we might get a good idea of what stuff our brain and body is responding to well and what stuff it is not responding to well, and therefore we know which is the thing that we want to be doing for 12 weeks and which is the thing that we predict after 12 weeks we really will see the change in. Now, I talked about the nervous system responding positively or negatively. The majority of the time, if you think of how many different bits of information are approaching your body all at once, the majority of the time the brain is just ignoring it. So it's just saying, you know what, there's so much information coming in, I've just got to decide, I've got to pick the few things that I think are important and work on that. When it comes to balance and vision and breathing and all those kind of autonomic unconscious things, we don't really get a say in what that is, but conscious attention can be really important. If we're trying to learn something as a skill for the future, then actually what we're paying attention to is going to really help the brain decide, oh, this is something that I want to take and run with, or this is something that I want to pay attention to see how I feel. So if we're doing things passively, if you're just on a treadmill with Netflix in front of you just watching it, or if you're always going to a massage therapist and they're not really doing anything to help you integrate that movement afterwards, probably you're going to see some changes. Your brain's not going to ignore it entirely because it's going to take the most important bits and focus on that. But if you want to see better changes and much quicker, what you're paying attention to will tell the brain, this is important to me, I should learn about this for the future. So if we're trying to assess the nervous system, very important that we're paying attention. If we want to be learning something for the future, also very important that we're paying attention. Okay, so that's kind of all of the survival stuff I want to talk to you about. I've got one more slide that's a little different, maybe a little controversial, I don't know. That is the idea: placebo is powerful. So I think it would be a mistake to talk about the nervous system if we didn't talk about the placebo effect. You might have heard about this in drug trials especially. It's kind of the bane of the pharmaceutical industry, because it's the idea that when you give people drugs, oftentimes it's not the drug that actually causes the positive change in people, it's their own brains. And when we're looking at neuroscience, it's useful to know that actually the right kind of mindset and the right kind of actions can cause a positive effect regardless of what it is that you're doing. I'm not going to go too much into all of the things that can affect the placebo effect, but one of the big things is your belief that something will work. And that can really make the placebo effect a really good thing and a really bad thing when you're trying to figure out what is best for your training. So on the plus side, having the right attitude, having a really open mindset, and being really motivated about your training and change in your body, paying conscious attention to what you're doing, and just all of that kind of positive side of things means you're more likely to see positive improvements in your training than not. On the negative side of things, how do you know that all of the expensive practices that you're buying into are actually working? How do you know it's that and not just the fact that your brain is going, hey, this is cool, I found something to occupy myself, and I'm consciously thinking about the change, so it's working. And unfortunately, it's very, very hard outside of scientific conditions, which are really hard to get in the human body, to be able to conclusively say these things one way or another. One of the things I think is important if you're going to be getting into training, if you're going to get into movement, you kind of want to have this really difficult mix of open-mindedness and skepticism, and the level of each that you have is going to be different for different people. I'll give you an example for myself. I like to, if somebody tells me about a new breakthrough in training, whether it's some sort of vision exercise that's going to make you faster, or something that's going to make you breathe better, or something that's whatever change it's going to make, I pretty much believe them right away. I'm very gullible. I will just straight away go, oh, cool, I want to try it. If I can afford it, then I'm going to test it out. I'm going to test it out on myself. If I see positive results, if I see positive benefits, I'm going to go, great, I'm going to keep doing it, and I'm going to try it out. And now I'm going to bring it to maybe my circle of friends. I'm going to go, hey guys, you all need to try this. I've tried it, it worked on me. Again, super gullible, no testing done at all at this stage. I've just asked a load of other people to buy in and try stuff. If it's working on them, and this is still my circle of friends, this isn't my clients or customers, just to be very clear about that. If they're starting to see positive benefits, that's the point where I'm going to start asking questions. So I'm going to say, okay, cool, this is really interesting. Does it really work? How does it really work? What do we know about it? What is it not possible to know about it? And then from there, I will make the informed decision of, am I going to bring this to my clients, to my customers? Am I going to keep doing it myself? And, most of the time I find it helped me a lot in the beginning, and then it kind of peters off, and I start to look into it and research it, and turns out not so much evidence that backs it up or supports it or even explains why it might work, and then I move on to the next thing. That works for me. I feel like I don't cause quite a lot of harm. The most harm is potentially to myself, and I'm comfortable enough with my knowledge about my body and the kinds of people that I talk to that I don't think I'm going to do too much damage there. If you're a physiotherapist or a doctor, obviously you're probably going to want to, you're probably already just going to have the habit of being more skeptical than I might be initially, and you're going to want to read through a lot more information before you even consider trying it. Like I said, it's really up to you how far you want to go either direction. The important thing is just to be aware. it's this huge gray area in training and movement, and really the only thing that you can do is just keep analyzing, keep testing. You just remember you will get the most benefit out of the placebo effect if you're willing to remain at least positive about the experience. So if you can be a bit open-minded, that can be really useful. But you actually, the more you can be testing things, the more you can be trying things, even with that positive mindset, the more likely you are to be able to hone in on the stuff that's really working and good for you and the stuff that's really not. I hope that doesn't put you off all the training that we do. I didn't want to ignore this because I think it is really crucial for any kind of practice. If you're going to get into something, there are tons of things on the market. There are tons of people trying to market things to you. You really do need to test as much as you can. The more data you can collect, the more likely you are to get a conclusive answer. But even that, you're probably never going to know so much either way. So find the things that fit in with your kind of lifestyle and training choices as well as you can, as well as test all these things as much as you can. And then after that, you're just going to have to weigh up, what do you think's a good idea? What are you going to throw out? So there we go. All right, so that is the 5 concepts about the nervous system. I hope all of that was clear enough. Please let me know if you have any questions about it. Otherwise, thank you very much for watching, and I'll see you in the next one.